Hello.
Yes, sir.
Okay, shall we start today's session?
Yes, sir.
So last time we have discussed how to draw the bending moment diagrams. First, in the beginning, we discussed the reaction calculations which are required for bending moment and shear force calculations. So I think we have started with one problem only last time to understand the bending moment and shear force. We have taken one cantilever example, simple example. Now we will take some more examples today. See, because bending moment shear force is very important topic as far as structural engineering is concerned, because whatever we design the columns or beams, they are based on the bending moment and shear force. So you should know the analysis part of the bending moment. Last time we have discussed the sign conventions regarding the shear force. I think please keep this in mind. Let's say if we are considering this section, and if you are considering the left side part, if left side part is upward, then I can say it is positive shear, and right as downward. So this value we can call it as a positive value as far as shear force is concerned, SF. And if the section is there and if the left side part is downward and right side is upward, then I can say it is a negative shear force. So in short, I can say if you can see this figure, this arrow is upward, this is downward, that means this is a clockwise. So this shear is clockwise, right? So you can understand clockwise we are assuming here as a positive, and anti-clockwise assuming negative as far as shear force is concerned. So this is the convention for shear force. And there is one more convention, that is nothing but moment convention. So if to the left side, if it is clockwise to the left side, then I can say it is a positive, or anti-clockwise at the right side, then it is a positive. And if it is anti-clockwise on the left and clockwise on the right, then it would be negative. Okay. So this this moment I can say this is a sagging moment. If you see this figure, this is a sagging moment. And if you see this, then this will form this kind of curvature. So I can say this is a hogging moment. Please remember these conventions. These are standard conventions, we can say, whatever we have used in the books. Are you getting the sign conventions?
Yes, sir.
So this is for shear force. And this is for moment. Now let's take one more example for this. I'll do one thing here. Okay. Now let's go to the example. Let's say we have one simply supported beam. And let's say we are having one point load here somewhere. Let me take the dimensions like this. So let's say let me divide this in different parts. So this every part is a 1 meter part, we can say. So from here to here, then this is 1 meter. Then from here to here, it is 1 meter, 1 meter and 1 meter. And the point load we can assume as a, let's say 10 kilonewton. Okay. So tell me what will be the reaction. Let's say this is A and let's say this is B. So what will be the reaction at A and B?
5 kilo.
So keep in mind this is different. So it is eccentric load 1 and 2 meters. So this distance is 2 meters and this distance is 3 meters. Total span of the beam is 5 meters. So RA will be how much? So you can do that. This is RA and this is RB. So you can use those equations, equilibrium equations.
6. So 6 RA will be 6 and RB will be 4.
Let's say sigma about A is 0. Then this will be anti-clockwise. What we are assuming? Minus or plus. What is the sign convention for equilibrium conditions? So this is our sign conventions, right? So let's say clock, and this is your positive conventions. Whenever you calculate the reactions, use these conventions, and whenever you calculate the shear forces, use these conventions. So these are different. Don't get confused with this. Now we are calculating the reactions. So how moment about A? So 10 into 2 clockwise positive. So 10 into 2 and minus RB into 5. Yes, will be 0. So what will be RB?
4.
4 kilonewton. And then Fy is equal to 0. So this will be RA plus, RA minus 10 plus RB is equal to 0. So RB का value कितना है हमारा? We have the RB value as 4. So RA will be
6 kilonewton.
so 6 kilonewton. So this is your 6 kilonewton and this is your 4 kilonewton. Okay. So before drawing any bending moment and shear force, you must know the reaction first. Okay. So generally, whenever you consider the supports, you can call the support because there is a shear force at the support always due to the reaction. So this VA will be 6 kilonewton and at this RB, I can say VB, that is shear force. So whenever you have the reaction at the support, they are the shear force at that point, generally. Now we are interested in the shear force and moment diagram. So let's say if I ask you what is the shear force, I'm considering this section first. Okay. So let's start from the left hand side. So you can choose any side. Let me consider the left hand side. So if I draw that piece, so what are the forces in this? So there is a vertical force, which is this one 6. And is there anything there above? Above? Nothing is there, right? So I can say as far as the shear force is concerned, if this is the 6, then there will be shear force 6. What will be the shear force here? Shear force is nothing but the summation of all the vertical forces to the left side. So what will be the shear force at this point?
6 only.
6 only, because summation of the all forces at this point is 6. Then if you go over here, then this 6 and there is nobody. So it is same. So I will draw this like this. So shear force, this shear force will be, and which is the direction? It is upward. So I'm just transferring this summation here. So this is your 6 value. Okay. Now what else will be there? Due to this force, what will be there? There will be the moment about this point, right? So this 6 into this 1. So what will be the moment? 6 into 1.
Kilonewton.
So it will be 6 only, yes?
Yes, sir.
6 kilonewton meter, and this is 6 kilonewton shear force. Now you can see here. Now, as we know that there has to be equilibrium at any section. At any section of the member, there is always equilibrium. That means I can say to the left side, if these are the forces, to balance this, there has to be equal and opposite forces. So this one and this one, right? So this will be 6 and this will be also 6. We are because then and then there will be equilibrium equation. I hope you are getting this. Now this is with respect to this point. Now if I consider the section at this point load, and at this point load, but just to the left side. So let's consider the section just to the left and draw this diagram, loading diagram, we can say. This is a loading diagram. So I can say so we have this 6. Now I'm considering this is the 2 meter distance from 1 and 1 2. So this distance is 2 meters. 2 meters. Now, is there anybody here? If you see this diagram, there are no forces to the left side. Yes, left side of the blue color section. Only there is a vertical reaction, which I have drawn here. Now, what is the shear force? It is the summation of all the forces, vertical forces, summation of all vertical forces to the left side. So is there anybody? Nobody. So this 6 will be directly, we can say this, there is a 6 force here also, and it will be uniform till this point. And what will be the moment? 6 into
12 kilonewton meter.
yes. So it will be 12. And as I already said, for equilibrium, it should be equal and opposite. So it is clockwise. Then there has to be anti-clockwise moment. Correct. Now, if you consider just to the right of this blue color, let's say, let me consider this portion just, okay, just to the right, I'm saying. So the distance will be 2 meter only, but just taking. So if you consider that, so it will be same here. As I'm considering just to the right, there is a downward force of 10 kilonewton, right? This is your 6, this is your 10, and this is your 2 meters. So what will be the shear force at this point? यहाँ कितना आएगा? So let me just draw it. थोड़ा आगे निकलता हूँ for this. So if I want to draw the shear force, what will be the shear force here? This plus 6 minus 10, how much is the value?
-4.
-4.
So -4 means it will be downward. Okay. Instead of writing minus, I'm just putting the arrow opposite. So see, this is positive because this plus 6 plus 6. Now this plus 6 minus 10 will be -4. So show it downward. And what will be the moment? This is just matching the section. So 10 into, assume this as a 0. It is just to the right. So it is as good as 0. So 6 into 2, how much? 12. Which direction will be there for the moment?
Clockwise.
So it will be. Now let's go to the next section. let's go directly here now. So you can use the same procedure for this section also. Let's go here directly. So let me say this as a C, then this section as D, E, and F. Okay, so we have discussed this section C here, then section D over here. So this was D left, just to the left of the point load, and this is D, but right. Now let's take directly F. So if you consider the F section, यहाँ तक आ रहा है, something here. This is F. Okay. So we know that there is a force here, which is 6. This one. Then there is a point load over here, 10. और यहाँ से ये distance कितना है? How much is distance? From point load F is at 2 meters. From point load F is at 2 meters. So this is 2 meters, and this is also 2 meters till the point load. I think so. Yes, 2 meters. Now we are interested to know the shear force at this point. So how much will be the shear force? कितना रहेगा? This plus 6 minus 10. यहाँ कितना आएगा? Minus 4. So downward I am just showing. And what will be the moment at this point? Moment is 6 into how much? 6 into 4 ना? यहाँ तक clear है ना moment. So 6 into 4, and this there is a downward moment. So this will be clockwise, and this 10, that is minus 10 into 2. समझ में आ रहा है कुछ? Hello?
Yes, sir.
So we are interested in this section. So what is the distance of this section? 2 plus 2, 4. So 6 into 4 will be, so I am taking clockwise positive. So whenever I consider the moment or reactions, clockwise positive. And then my anti-clockwise, 10 into 2 will be anti-clockwise. So I am putting this as minus. So how much is the value? 4 kilonewton
4 kilonewton
meter, right? And what will be the, so this is to the left side, and what will be the shear force at this B point? B point पे कितना रहेगा? So in this case, you can think of, यहाँ कितना रहेगा shear force ये point पे? So we are till B, F. So यहाँ का shear force और bending moment निकालना होगा, तो क्या करना पड़ेगा? Yes.
0.
Let's take just to the left of the B. Okay. So see, procedure is same. There is no change in that procedure. So अभी ये यहाँ तक मैं ले रहा हूँ. So this is your 6. This is your 10. ये मेरा 2 मीटर है यहाँ तक, and then यहाँ तक ये मेरा B point है, B point. Okay, B मतलब वो support है हमारा. So I'm just taking just to the left. As I am taking just to the left, that means this reaction will not come in picture. RB का नहीं रहेगा. Now let's calculate the shear force. अभी यहाँ कितना आएगा बताओ? Whenever I say just to the left of this, मतलब this RB will not come in picture. I'm just taking to the left. यहाँ कहाँ तो ले रहा हूँ. That means reaction is exactly at the point, not to the left side. So I'm ignoring here the reaction like this. अभी मुझे बताओ कितना आएगा shear force यहाँ?
-4.
It will be -4, so downward. And moment कितना आएगा? अभी यहाँ से distance कितना है हमारा point load से आगे? 1 to 3 मीटर है. So this is your 3 meters from here. ये 3 मीटर है यहाँ से यहाँ तक. तो moment बताओ कितना है? 6 into, yes,
5.
and
0.
minus 10 into 3 यहाँ से यहाँ तक. So what will be the value? 0. मतलब at RB Here the moment is 0. So all of you know that at hinge connection, we have the moment at 0, bending moment at 0. So whenever there is a simple support like hinge or roller, we have the bending moment 0. So I will not draw any bending moment at this point. So there will be only shear force. Now, if you want to draw the shear force diagram, and as I already said to you, हाँ तो यहाँ moment draw करना बाकी है ना. So what is this is plus value. So if it is a plus, then what is this, clockwise or anti-clockwise?
Clockwise.
This is reaction we are talking. So clockwise, it will be clockwise 4. Correct. Then यहाँ कितना आएगा moment?
0.
It will be 0. And यहाँ 12 आ रहा है. So let me write ये section का point में mark करता हूँ. So let me. So this is my which point? C point है मेरा. Then I have D. Then I have ये भी D है. And F. Now let's draw, and this is your B directly, and ये हमारा A है left side. So if you want to draw the shear force diagram first, let's start with the shear force diagram. तो अभी थोड़ा ऊपर नीचे करना पड़ेगा इसको. Okay. So this is my A point, this is my B point, and this is my C, D, E, and F. Now what is the shear force at A point? A point पे कितना रहेगा shear force?
6 kilonewton.
6, because the reaction itself is a shear force. And what is the direction of it? Upward, right? And whenever the direction of the shear force is upward to the left side of the section, is it positive or negative? क्या है हमारा साइन कन्वेंशन, क्या बोल रहे हैं?
Positive.
सेक्शन के लेफ्ट को अगर अपवर्ड रहेगा, then it is a positive. So I will start drawing the shear force as positive. So ये मेरा, ये समझो ये हो गया मेरा. So this is my 6 point. So this value is nothing but 6 kilonewton, right? Now यहाँ से C point तक कितना shear force है? So what is the shear force to the left side of the C? तो ये है ना मेरा. यहाँ कितना है मेरा shear force at point C? ये हमारा C point है. 6, which is upward to the left side. That means वहां भी 6 ही है. इसका मतलब till 6 point, till C point, we have a constant shear force 6. यहाँ तक तो 6 ही दिख रहा है मुझे, right? Now what is the shear force at D point? Just to the left, ये left side just कितना है? 6 upward. That means again it is positive 6. मतलब ये भी constant है इसके आगे भी. Now just to the right of D, कितना shear force है मेरा ये?
-4.
-4, because it is downward, because minus, so that means shear force is negative. To the left it is downward. Here you can see to the left it is downward 4. So that means it is now changing its direction like this. So यहाँ तक कहाँ तो आएगा मेरा value. Okay, and what is this value? 4. Now what is the shear force at F? कितना आ रहा है ये? Downward 4. That means it is constant till F. Now E पे भी निकाल सकते हैं आप. So you will see that it is same. E पे निकालने के बाद. So till F it is same. And what is the at point B just to the left? कितना है shear force?
-4.
Again it is same. So it is constant till this point, we can see. Now this is a minus value of the shear force. and this is your plus value of the shear force. So ये भी मेरा 4 है और यहाँ मेरा 6 है till this point. Just to the left 6 है, just to the right -4 आया, इसलिए नीचे गया ये. So this is your shear force diagram SFD. Got this? Got the shear force diagram?
Yes, sir.
Now let's go to the moment diagram, bending moment diagram. See, if the people are finding difficult, please just listen to this. You may understand. You practice on this for different loading conditions, supporting conditions. As practice, you will understand. In practice, actually, you have to just keep in mind the sign conventions. So if you are calculating any reactions for calculations, then these are the sign conventions, positive. And if you are drawing any bending moment or shear force diagram, so shear force, this is the sign convention. For moment, this is the sign convention. Now let's start with the bending moment. अभी ये point है मेरा, समझो. What is the bending moment at A point?
0.
0, because it is hinge connection. So यहाँ ये तो 0 आएगा. Okay. Now what is the bending moment at C point? C point पे भी निकाला है ना हमने bending moment. कितना था वो? कितना ये?
6
6.
kilometer.
Clockwise मतलब left side को clockwise. ये क्या है?
Positive.
Yeah. So positive. Now if this point load is there on this beam, how will it bend? Bend कैसे होगा ये beam? The beam will bend like this. ऐसे bend होगा ना?
Sagging, sir.
हाँ, ऐसे sag होगा ना? So generally, whenever you draw any bending moment diagram, draw on the, so tension will be at the bottom. So we will draw the bending moment diagram at the bottom side. Okay. So even the, now what is the value? 6 kilonewton. Is it positive or negative?
Positive.
Because of
Positive,
this sign,
sir.
yeah, this sign convention. So positive रहेगा तो फिर, but even though it is a positive, I will draw to the downward side. Here shear force मैंने ऐसे ऊपर draw की है. But whenever you draw the bending moment diagram, please draw it on the tension face of the beam. तो ये नीचे का निकलता हो, even though it is positive. So what is the value at point C? C point पे कितना आ रहा है मेरा value? 6. What is the value just to the left of D? कितना ये moment मेरा? 12. Right? Clockwise है, मतलब again positive. तो ये point पे मेरा यहाँ कुछ तो आएगा ये, right? ये 12 है समझो. Then F point पे कितना आ रहा है? Clockwise 4. मतलब clockwise मतलब positive. तो ये F point पे कितना आ रहा है मेरा? 4. And if you calculate at D point पे it will be 8 something. If you calculate, अभी मैंने लिया नहीं वो section, but you can take that for your homework as a part. Now at that point C, it is 6 clockwise, therefore it is positive. I am drawing on the downward side the positive values. Then at D, the value is positive 12, so again it is same direction. Then here ये 8 आ रहा है यहाँ, and then यहाँ 4. And at B कितना आएगा moment?
0.
0, sir.
That means now yeah, 6, 12, so they are linearly proportional. So if you see, whenever you now अभी जब moment में निकाल रहा था यहाँ, so 6 into 2 किया ना मैंने यहाँ, whenever I draw calculate the bending moment, ये क्या किया मैंने? 6 into 2, मतलब 6 into क्या किया मैंने? समझो कुछ distance है ना x. Are you getting? 2 is some distance.
Yes, sir.
Single. So 6 into x. So if you, so what is this function? There is some constant value, let's say m, and there is a x. So what is this function? mx मतलब क्या रहता है? What do you understand by this function? F is equal to mx. Maths में सीखा था ना? mx is what?
Yes, sir.
So this is nothing but
slope.
a sloping line. Yes, sloping line. Because some constant into distance. So this is a sloping line, and that's why you will see here all, see whatever moment we have calculated this 6 into this distance minus this 10 into this distance. So this is your x, I can say any dimension, x whatever. So you are multiplying some number with that distance, and therefore it is a sloping line, and we will get the sloping. So if you connect these lines, you will get the sloping line like this. And if you collect these lines, then you will also get the sloping line, right? समझ में आया? The values at this point, ये 4 रहेगा, ये 8 रहेगा, this one is 4, this one is 12, this one is 6. Okay, and this is your positive. I am just drawing. That means it is a, whenever the moment is positive, यहाँ दिखाया है हमने, ये positive है, मतलब sagging है, yes or no? So this is my sagging bending moment. So I can, so ऐसे है ना मेरा, ये sagging का meaning है ऐसे, ऐसे ही value आए थे ना मेरे. So this is your positive value. Got how to calculate the bending moment diagrams, bending moment values and diagrams?
Yes, sir.
समझ में आया? आसान है ना? So the procedure is same for all kind of problems. So shall we quickly do some other equation? अभी दूसरा करेंगे. अगर ये point load रहेगा, अभी क्या करेंगे? Quickly मैं निकलता हूँ. अभी थोड़ा, I don't know whether you will be able to do that, but let's see. Abhi, see, this is the procedure. If you find any difficulty in understanding bending moment calculations and diagrams, go with this procedure always till you understand the concept. So यही procedure है, एक section लेने का, वहां तक वहां shear force and bending moment का values निकालने का. Again take the next section. Always take the section at the point loads. Always just to the left, just to the right. और यहाँ बीच बीच में ले सकते हैं, so that you will get idea कि ये actually line कैसे develop होने वाला है, या ये line कैसे. So whenever there is a point load, please take the section. ऐसे जैसे मैंने यहाँ निकाला है ना, point load के left को और right को, right? And that's why whenever there is a change in the direction of the shear force, change in the direction of the bending moment, you will understand, because point load पे always change रहता है. Yes. So whenever there are many forces here, you take the shear force bending moment at every section. Now let's quickly take the simple example. अभी ये simply supported beam है, समझो same, and I have 10 kilonewton force here, and let's say my span is 4 meters, so 2 meter here and 2 meter here. Okay, so this is your simply supported beam with the point load at the center of the beam. So tell me, how will you arrive at a shear force and bending moments? बताओ, अब ये कैसे bend होगा? Same जैसे
Sagging.
या ऐसे ही sag होगा. Okay, तो ये तो deflected shape is very clear to you. Now, first step is what for bending moment shear force calculations?
Reactions.
Yes, so you want reactions. तो यहाँ reaction कितना रहेगा मेरा?
5
So
5 kilonewton.
5 kilonewton and 5 kilonewton. Okay, so now Abhish, we want to draw the shear force diagram. Can you do it directly? कर सकते क्या आप? Let's try it.
Yes, sir.
Procedure तो same ही है. Try करो. तो this is my horizontal line. I'm just now this is 5. So as I already told you, the reaction is the shear force and it is upward. So let's say मैं यहाँ कहाँ तो section ले रहा हूँ. Okay, assume कर रहा हूँ मैं अभी यहाँ कहाँ तो 5 upward है, मतलब it will be positive shear force, correct? So this will be positive 5. अभी यहाँ कितना रहेगा मेरा? Same ही है ना?
5
Till this point, यहाँ तक मेरा वही है ना value?
Yes,
5 है
sir.
ना? So it will be constant till this point. अभी यहाँ कुछ हो रहा है क्या? If you take just to the right of this, क्या होगा value? 5, this plus 5 minus 10, कितना value आएगा?
-5.
So that means it will go down. ऐसे कुछ तो आएगा. So this was positive, now it is changing its direction. अभी यहाँ से यहाँ तक क्या रहेगा बताओ, समझो, just to the left यहाँ तक. This 5 minus 10 कितना आएगा वैल्यू? 5 minus 10 is minus 5, मतलब
-5.
so ये अभी ये मेरा 5 था यहाँ तक, ये 5 है, ये 5 है, यहाँ भी 5 है, लेकिन डायरेक्शन नेगेटिव है. And then I will again, so till this point again it is a 5 just to the left. तो support पे यहाँ ये हो जाएगा. So this is your balanced. So this is your negative. All values are 5, correct? And this is also, you can see, अगर if you take the right side of the section, कितना B पे है reaction? Let's say यहाँ से मैं अभी यहाँ लेता हूँ ये section, यहाँ just to the right of this. तो ये मेरा B है और यहाँ कितना है मेरा 5 है ना? राइट से करता हूँ. दिस कैलकुलेशन वी हैव डन फ्रॉम द लेफ्ट साइड. राइट में अगर अपवर्ड रहेगा फोर्स तो क्या रहता है? राइट में अपवर्ड रहेगा तो शेयर फोर्स क्या है? अगेन सी, इफ शेयर फोर्स नेगेटिव है, एंड दैट्स व्हाई यहाँ भी ये जस्टिफाई हो रहा है, ये नेगेटिव वैल्यू है, करेक्ट, ये इस पॉइंट पे. सो आइदर यू कंसीडर लेफ्ट साइड और राइट साइड, इट इज जस्टिफाइड. सो दिस इज योर शेयर फोर्स डायग्राम. अभी बेंडिंग मोमेंट डायग्राम कैसे रहेगा? यहाँ तो 0 है, यहाँ भी 0 है.
Yes sir.
नाउ लेट्स टेक डायरेक्टली एट द पॉइंट. अभी इस पॉइंट पे कितना रहेगा? 5
10.
into 10. एंड वैल्यू क्या है? ऐसे क्लॉकवाइज आने वाला है ना ये. तो व्हाट इज दिस वैल्यू, पॉजिटिव और नेगेटिव?
Positive.
Positive. And as I told you, draw the bending moment diagram on the tension phase. So, नीचे टेंशन आने वाला है, इसलिए नीचे ड्रॉ करो इसको. And why it is linear? Because this force into distance, मतलब m into x. So linear function है इसकी वजह से. Then what will be the value here? यहाँ निकलने के बाद see 5 into the same procedure. So you will see that now it is reducing the moments. So ऐसे reduce भी होगा. So it's very simple problem. So it will be directly like this. Now if you want to take any value in between, it will be linearly proportional. यहाँ उतना ही रहेगा ना, this distance. यहाँ समझो मुझे अभी I ask you the question. ये मेरा कितना डिस्टेंस है? 2 मीटर है ना. नाउ आई वांट द बेंडिंग मोमेंट, ये मेरा 2 मीटर है. आई वांट बेंडिंग मोमेंट एट 1.5 मीटर फ्रॉम हियर. सो यहाँ मुझे कहाँ तो चाहिए, ये मेरा 1.5 है समझो. सो व्हाट इज द बेंडिंग मोमेंट वैल्यू एट 1.5 मीटर पॉइंट? यहाँ से यहाँ 1.5 है समझो. यहाँ बेंडिंग मोमेंट वैल्यू कितना आएगा मेरा, बताओ?
7.5 kilonewton.
सो दिस 5 into 1.5 इज 7.5. मतलब ये वैल्यू जो बेंडिंग मोमेंट का यहाँ है, ये 7.5. और ये कितना है मेरा? 10. ये मेरा 0, ये मेरा 0. अगेन यहाँ कहाँ भी निकल सकते हैं आप. 1 मीटर पे कितना रहेगा मोमेंट? 1 मीटर पे यहाँ से यहाँ में 5 into 1.
5.
Yes, it will be 5 something. So this is your SFD, this is your BMD. I hope you got the concept. Let's switch over to the next problem. Now we will take different problems, simple problems. Now let's say we have a UDL of 10 kilonewton per meter. Span is 4 meters. A, B. Now कैसे करना है ये? So what is the first step?
We have to find reaction.
So reaction RA will be, RA and RB निकालना है ना मुझे. So 10 total load कितना है उसके ऊपर? 10 into 4.
40.
40 kilonewton will be the total load. Half will go
Yes, sir.
here. That is 20 kilonewton, and half will be to the right side. So I'm not going with the equilibrium equations. It's a very simple problem. We have already learned how to calculate the reactions. Now, as it is simple, I'm taking symmetric use. But if it is unsymmetric, we need to use these equations. यहाँ हमने निकाला ना, unsymmetric था ना. ये प्रॉब्लम अनसिमेट्रिक है, 2 मीटर यहाँ है और 3 मीटर यहाँ, इसलिए मैंने ये इक्वेशन यूज की है इक्विलिब्रियम की। अब यहाँ तो कुछ जरूरी नहीं है। नाउ यू नो द रिएक्शंस। अभी मुझे बताओ इसके पार्ट्स करने हैं कि आपको करना है वो तो कर सकते हो। अभी इसके 4 पार्ट करेंगे समझो। एक, लेट मी से इट सी डी ई, ओके, और सब पार्ट्स पे निकल देंगे हम शेयर फोर्स। अभी एक सिंपल पहले यहाँ निकालता हूँ आपको, बाद में फिर डायरेक्टली करेंगे। अभी लेट मी टेक दिस सी पॉइंट, यहाँ एक ड्रॉ करता हूँ। ये सी है मेरा, ये मेरा 20 है, ये मेरा डिस्टेंस कितना है सी का, ये 1 मीटर है। 1 1 1 4 मीटर के 4 पार्ट्स किए मैंने। सो दिस इज माय 1 मीटर डिस्टेंस एंड देयर इज अगेन, ये भी फोर्स है ना यहाँ, ये सी पॉइंट के लेफ्ट साइड को कितना फोर्स है मेरा। नाउ टेल मी व्हाट इज द शियर फोर्स। यहाँ शियर फोर्स कितना आएगा ये पॉइंट पे। It
10
is the
kilo.
summation
10.
of the force. So this 20 will be plus 20 minus 10 into 1. इतना ही है ना फोर्स, ये ऊपर and
Yes,
this is
sir.
downward. So what is this value
Yes.
from 10 which is positive. So positive मतलब
Upward.
upward. And what will be the moment? ये मेरा SF था, shear force था. What is the moment? At point C बोल रहे, SF at C, moment at C. 20 into 1 minus 10 into बताओ।
1/2.
Yeah, so it will be 10 into 1. 10 into 1 will be the force and the force will act at CG. So into 1/2. यहाँ से ये 0.5 है ना, 1/2 है ना ये। All of you know the UDL में कैसे करना है। तो कितना आएगा वैल्यू मेरा?
Yes.
15 मीटर, राइट। अगेन एट डी पॉइंट कितना आएगा? ओके, डी पॉइंट का भी निकालेंगे, सेंटर का, दोनों निकालेंगे। जस्ट लेट्स गो।
It will be 0 at D.
नो, अभी यहाँ ये मेरा डी है। डी का डिस्टेंस कितना है मेरा? 2 मीटर्स ना, और ये 10। Reaction is 20. Now SF at D. या मोमेंट मैंने, आई नीड टू शो द मोमेंट ऑल्सो। यहाँ दिखाता हूँ। ये मेरा मोमेंट का वैल्यू था। वॉज इट क्लॉकवाइज और एंटी क्लॉकवाइज? पॉजिटिव आया ना। सो ये वैल्यू कितना था? 15 किलो न्यूटन मीटर। ओके, नाउ लेट्स गो टू द शियर फोर्स। शियर फोर्स कितना आएगा? 20 माइनस 10 into 2, right? 0. And what is the moment at D? 20 into 2 minus, बताओ, ये तो आसान है। ये क्या है? 10 into
0, sir.
10 into 2 into 2/2, ये CG से, राइट? तो कितना आएगा बोलो?
20.
0, sir.
So it will be 0.
Also 20 आए.
नहीं, कुछ तो गड़बड़ हुआ है क्या?
20.
Sir, it will be 20 only.
It will be 20 ना, ये 40 है ना। हाँ, 40 minus
Yes,
20.
sir. Yes, sir. Sorry. 20. 20.
हाँ, 40 minus 20 किलो न्यूटन। ओके, सो डी पे। और ये 20 मतलब अभी डायरेक्शन कैसे रहेंगे हमारे? 20 मतलब पॉजिटिव आ रहा है, तो ये मेरा ऐसे रहेगा, ये 20। और शियर फोर्स का वैल्यू 0 है, तो नहीं लिखा तो भी चलेगा। सो देयर इज नो डायरेक्शन एज इट इज 0। नाउ लेट्स गो फॉर ड्राइंग। अभी यहाँ देखो, शियर फोर्स इज फोर्स इंटू डिस्टेंस है, मतलब m इंटू एक्स है यहाँ। तो यहाँ देखो, नाउ लेट मी टेक, ओके, थोड़ा यहाँ मैं एक दिखाता हूँ। अभी मुझे है ना, इफ आई वांट टू calculate the shear force at any point which is at a distance x from here. Okay, पहले ये एक कंसेप्ट बताता हूँ. अभी यहाँ चाहिए shear force, अभी यही प्रोसीजर है एक्चुअली. तो x पे चाहिए shear force. समझो ये मेरा x डिस्टेंस है, ये मेरा x है. ओके, दिस सेक्शन इज एट अ डिस्टेंस x फ्रॉम दिस. अभी ये वैल्यू रिएक्शन का 20 है, ये कितना है 10. नाउ व्हाट इज द shear force वैल्यू एट दिस पॉइंट एंड मोमेंट वैल्यू एट दैट पॉइंट. तो shear force का वैल्यू कितना रहेगा SF एट x सेक्शन, कितना रहेगा बताओ? 20. यस,
minus 10x.
into minus 10 into x.
Yes, sir.
Okay, so this will be my shear force at x. And what is the moment at x? 20 into x minus बताओ 10 into x is the force,
X,
and where it will act? X by.
x by 2.
So ये 20x minus 5x square आएगा ना. Okay, getting?
Yes, sir.
Now if you look at the shear force equation, you will see 10x is there. And what is the 10x matlab mx, and what is this mx? Sloping line.
Slope.
And there is a x square here and x here. So what is this function? X square किसका function रहता है?
Quadratic.
No, it's मतलब ग्राफ कौन सा आएगा इसमें? अभी इसमें जैसे
Parabolic.
स्लोप लाइन आएगी ना, जैसे ये पैराबोला का
Parabolic.
so equation of parabola, right? That means your bending moment diagram will be parabolic in shape and your shear force diagram will be sloping in shape, right? ये समझ में आया कुछ? For this problem, I am talking for this problem. Now let's go to the, that means अभी जो drawing निकालने वाले हैं, it has to follow this. So अभी इसको थोड़ा सा मूव करता हूँ. Now let's go to the bending moment. We can start with the shear force first. ये मेरा समझो ये है. So what is the shear force at this support? Same as reaction, which is 20. ये मेरा 20 वैल्यू आया. अभी यहाँ कितना है shear force मेरा? At point C, not C, क्या है मेरा? D है ना. D पे कितना आ रहा था shear force?
0, sir.
हाँ, ये 0 है यहाँ, मतलब यहाँ तो 0 आएगा. अभी यहाँ से यहाँ तक इसका क्या रहेगा? ये स्लोपिंग ना, क्योंकि स्लोपिंग आएगा ना.
Yes, sir.
एंड इफ यू डोंट नो ये स्लोप आएगा कि नहीं तो फिर यहाँ भी एक पॉइंट पे निकाल दो shear force, एंड देन यू विल सी कि ये लीनियरली ऐसे जा रहा है. तो ये मेरा अभी मैं डायरेक्टली निकालता हूँ. इफ यू आर इंटरेस्टेड कि बीच में क्या हो रहा है, अगर समझ में नहीं आ रहा, देन यू कैन डायरेक्टली टेक एनी सेक्शन. अभी यहाँ भी एक सी पे ले लो या बीच में भी ले सकते हैं, कहाँ भी ले सकते हैं सेक्शन, एंड ड्रॉ ईच एंड एवरी पॉइंट. यू विल से whenever you join these points, it will follow this. Correct? And same procedure, left side से start करो. As you go ahead, you will see कि ये ऐसे आपका डायग्राम तैयार होने वाला है. और ये वैल्यू मेरा ये भी BC होने वाला है क्योंकि राइट साइड के 20 है ना. So that means, so you can do same procedure follow जो मैंने यहाँ बताया था ना पहले वाला. सेम प्रोसीजर से ये निकल सकते हैं, बट बाय जजमेंट बाद में आपको आइडिया आ जाएगा कि ऐसे रहते हैं. सो दिस वैल्यू इज पॉजिटिव, दिस इज योर नेगेटिव वैल्यू due to the sign convention of shear force SFD. So this is your SFD. This value is also 20 and this is linear because of that function mx. Yeah, mx आ रहा है ना यहाँ 10x करके. And what will be the bending moment diagram? टेंशन कहाँ आएगा, बॉटम को या टॉप को?
Bottom.
बॉटम को. So I'll draw it on the bottom side. And what is the bending moment at point A पे कितना रहेगा? 0.
0, sir.
Simply supported है. अभी let's take at center कितना आ रहा है? Center point मेरा कौन सा है? D है ना. यहाँ कितना आएगा? मोमेंट एट
20.
डी इज
20 सर।
सो यहाँ ये पॉइंट 20 रहेगा मेरा. ओके. और यहाँ निकाला, वेन एवर यू टेक एनी एट दिस सेक्शन यू विल सी इट इज फॉलोइंग द पैराबोलिक शेप. बीच में वैल्यूज तो रहेगी, ऐसे रहेगा कुछ तो. ओके. सो इफ यू कैलकुलेट यहाँ एट दिस पॉइंट, तो यू कैन use these equations same and calculate each and every point. So if you calculate each and bending moment at each and every point, and if you connect these lines through these points, you will form a parabolic shape like this. So I'm not interested in all these values, because I'm interested in the maximum bending moment values in the design. So generally ये निकालते नहीं हम. I'm interested in the maximum bending moment, either it is sagging or hogging. And so this will be your positive value. पॉजिटिव आ रहा था ना यहाँ 20 क्या पॉजिटिव है ना. एज इट इज अ पॉजिटिव आई कैन से दिस इज माय, ये मेरा पॉजिटिव डायरेक्शन रहता है ना. ऐसे लेफ्ट को ऐसे रहेगा समझो, या राइट को ऐसे रहेगा. सो दिस इज माय पॉजिटिव एंड इट इज नथिंग बट माय सैगिंग मोमेंट लाइक दिस. ये डिफ्लेक्टेड शेप निकल रहा हूं मैं. ओके. सो दिस इज द बेंडिंग मोमेंट डायग्राम फॉर सिंपली सपोर्टेड बीम्स. So in the similar fashion you can calculate bending moment for different loads. अभी कैंटिलीवर का बताओ quickly. चलो. Now I will just go directly with the. So I hope you understood the concept. Now let's go directly. ये समझो मेरा कैंटिलीवर है, इसके ऊपर पॉइंट लोड है. अभी क्विकली निकालेंगे. ये 10 किलो न्यूटन है. ये मेरा 2 मीटर ले लूं क्या? 4. ठीक है 2 मीटर लेता हूं. ओके. एंड दिस इज योर ए पॉइंट, दिस इज योर बी पॉइंट. रिएक्शन कितना आएगा यहाँ बताओ?
10.
सो इट विल बी 10. और कुछ रहेगा रिएक्शन यहाँ? मोमेंट
The
10
moment.
into 2. So ये मेरा डायरेक्शन पे मोमेंट रहेगा, which is nothing but 10 into 2 is 20 kilonewton meter, right? ये 10 kilonewton reaction. So for calculation of bending moment shear force, we need reactions. So I have calculated the reactions. Now go with the. Let's draw the shear force. Oof. Now this, let's start with the left side. तो 10 है upward. तो यहाँ मेरा कैसे आएगा? 10 आएगा ना upward. यहाँ तक तो 10 ही आएगा मेरा. अभी यहाँ कितना है? यहाँ मैंने सेक्शन लिया बीच में, कहा तो इट्स एनीवेयर. सो 10 ही आ रहा है ना.
Yes sir.
यहाँ लिया तो लेफ्ट साइड को अगेन 10.
10.
That means you can say that it is very uniform shear force till this point at the end. राइट साइड से निकालो तो भी 10 ही दिख रहा है. So and what is this, positive or negative? क्या है ये? This was upward.
Positive.
Positive.
So this is my shear force diagram and this is my 10 value. This is also my 10 value. Now let's see the bending moment diagram. So bending moment में now where will be the tension cantilever में?
Upward. On the
Top side, right?
top side. Yes.
Okay. Now what is the bending? You can start with left side or right side, whatever you want. Let's say if you are comfortable with left side. अभी यहाँ मैं निकालता हूँ जस्ट यहाँ. तो यहाँ मोमेंट कितना है मेरा? ये पॉइंट पे, सपोर्ट पे पॉइंट पे मोमेंट कितना है? अभी 0 नहीं है, फिक्स है. 20 है, क्लॉकवाइज है, मतलब
Anti-clockwise it will be.
अरे हाँ ये क्लॉकवाइज तो मेरा ही है. राइट राइट, दिस इज रॉन्ग. क्योंकि ये मेरा क्लॉकवाइज है तो रिएक्शन विल बी एंटी क्लॉकवाइज. करेक्ट. उल्टा हो गया तो ही. राइट. नाउ एंटी क्लॉकवाइज लेफ्ट पे रहेगा मोमेंट, तो क्या है डायरेक्शन? इज इट नेगेटिव और पॉजिटिव?
Negative.
नेगेटिव. सो कितना वैल्यू रहेगा यहाँ? 20. सो लेट्स से दिस इज योर 20 वैल्यू. सो यहाँ से यहाँ तक 20 है. यूनिफॉर्म है ना, इसलिए मैं यूनिफॉर्म निकल रहा हूँ. दिस इज योर 20 वैल्यू. अभी यहाँ कितना समझो, मैं 1 मीटर पे ले रहा हूँ. लेट्स से दिस इज योर 1 मीटर. यहाँ से 1 मीटर है समझो यहाँ तक. So कितना आएगा मोमेंट एट दिस पॉइंट? इफ यू डोंट एज ए बिगिनर ऐसे भी कर सकते हैं, जस्ट कट दिस पोर्शन। ये मेरा 2 मीटर है ना यहाँ तक, सॉरी 1 मीटर है ये, एंड ये मेरा सेक्शन पॉइंट है, एंड आई नो द फोर्सेस एट दिस पॉइंट। तो ये मेरा 20 है किलो न्यूटन मीटर, एंड ये मेरा शेयर फोर्स 10 है। व्हाट इज द शेयर फोर्स एट दिस पॉइंट? 10 ही आएगा, तो यहाँ तो 10 इज रिफ्लेक्टेड। नाउ व्हाट इज द मोमेंट एट दिस पॉइंट? समझो इसको मैं सी बोलता हूँ। सी पे कितना रहेगा मोमेंट?
10 only.
ये अपन ड्रॉ सी कैलकुलेशन मुझे बताओ, ये प्रोसीजर, ये डायरेक्शन है एंटी क्लॉकवाइज, मतलब क्या है ये?
-20.
एंड ये 10 into 1 प्लस 10 into 1,
Yes, sir.
कितना है वैल्यू ये? माइनस
-10.
-10 किलो न्यूटन मीटर। तो यहाँ मेरा -10 है। ये कितना था? 20 किलो न्यूटन मीटर ये मोमेंट है मेरे, ये दिस पॉइंट। यहाँ मेरा -10 है, मतलब नीचे कहाँ तो आएगा। ओके, सो इफ यू सी दिस, ये मैं क्या कर रहा हूँ यहाँ, फोर्स इंटू डिस्टेंस, 10 into 1 मतलब फोर्स इंटू डिस्टेंस, मतलब ये m into x है ना, मतलब ये दिस विल फॉलो द स्लोपिंग लाइन। और व्हाट इज द मोमेंट एट दिस पॉइंट?
0.
सी आइदर यू एज्यूम इट और कैलकुलेशन करने के बाद भी यहाँ 0 ही आने वाला है। सो 10 into 2, सी ये कितना है मेरा? -20, एंड 10 into 2 कितना हो गया?
20.
+20। सो इट विल बी 0। सो इट इज जस्टिफाइड कि इस पॉइंट पे मोमेंट 0 है। Now see, by our common sense and our previous knowledge, we know that at free end the moment is zero, and at simple support it is also 0. So ये समझ में आता है इसलिए। But if you want to prove it by calculation, ये prove कर सकते हैं। यहाँ इस you take the moment at this point and then calculate like this. That means this is my ये है मेरा 10 का वैल्यू इस पॉइंट पे, and this is my negative value आ रहे थे ना ये सब, this is my negative value, and whenever I say negative it is nothing but my hogging moment. Okay, so it follows this curvature, ये ऐसे curvature रहेगा ना। So this is your BMD. Got this? Now again go to the, say I'm just taking many problems because BMD SFD is a very important topic. अभी quickly बताओ मुझे, अभी final answer ही चाहिए मुझे। Let's say this is 10 kilonewton per meter, cantilever, span is 2 meters, this is AB. What will be the reaction? Reaction बताओ directly, अभी आना चाहिए ना quickly.
20 kilonewton.
It will be 20 kilonewton, 10 into 2. Okay, then moment will be this moment is action moment is in which direction? As force is downward, it will be like this,
Clockwise.
right? So as it is clockwise, reaction will be anti-clockwise. What is the moment at this point? ये point पे
20 only.
so you can say moment at A will be, अगर चाहिए तो calculate करो, ये clockwise है मतलब positive है ना, 10 into 2 into 2/2, so 20 only, so this will be 20 kilonewton meter. और यहाँ कितना रहेगा moment? 0. So if I draw the bending moment diagram, let's say पहले shear force निकालेंगे, चलो let's say shear force here, what is the value? 20. So यहाँ 20 आएगा, so this is your 20. Then बताओ अभी shear force का diagram कैसे आएगा? So will it be straight line or okay? If you are confused, then you
Sloping,
can
sir.
यहाँ निकालो, नहीं तो फिर ऐसे as start with the fundamentals, no worries, till you get the feel of that you can start with the fundamentals. यहाँ समझो 1 मीटर है मेरा, ये मेरा UDL है, ये मेरा रिएक्शन है 20, सो यहाँ मेरा shear force कितना आएगा? This will be 20 minus 10 into 1. shear force कितना है मेरा यहाँ? हाँ?
+10.
प्लस 10 आया, और मोमेंट कितना आएगा? मोमेंट विल बी 20 into 1 minus 10 into 1 into 1 by 2, मतलब 1 square by 2. कितना है ये वैल्यू?
15.
15. ओके, एंड एज स्क्वायर आ रहा है ना यहाँ, डिस्टेंस का स्क्वायर आ रहा है, इसका मतलब ये क्या, कौन सा शेप है? पैराबोला, लाइन या व्हाटएवर?
Parabola.
सो माय मोमेंट डायग्राम विल बी पैराबोलिक, एंड माय दिस डायग्राम क्या रहेगा? ये डिस्टेंस है ना x, सो दिस डायग्राम विल बी स्लोपिंग लाइन, shear force.
Sloping.
तो ये मेरा 10 आ रहा है, मतलब यहाँ 20 था, यहाँ 10 है, एंड यहाँ कितना आएगा shear force at this point?
0.
0. If you don't know, you can calculate by this method, no worries. So this is your SFD. Now let's draw with the BMD. So what is the moment at the, ये point पे moment कितना आ रहा है मेरा? Anti-clockwise 20. So as I said you, even though anti-clockwise मतलब negative आने वाला value, but I am still drawing on the top for on the tension side. तो ये मेरा 20 value है. Free end को कितना रहेगा? 0. And what is this diagram? Parabola. थोड़ा और निकलता हूँ, negative value, correct? So this is your BMD. Got this? We'll take 2-3 minutes break. We'll start again. Okay. Hello.
Yes, sir.
Okay. Hello. Hello, are you there?
Yes, sir.
Okay.
Yes, sir.
So let's say homework for you. So let's say there are 2 point loads. This distance is 1 meter, this distance is 2 meters, and this distance is 1 meter. Point loads are 10 kilonewton, 10 kilonewton. Okay, so draw the shear force and bending moment diagrams for this problem. Can you directly draw this? कर सकते visualize
Yes, sir.
directly.
Yes, sir.
So shear force निकाल दे, बाकी bending moment you take it as a home work. Okay, so let's say ये कितना आएगा reaction?
10.
This will be 10, this will be 10. So as it is upward, ये ऐसे जाएगा,
Yes.
ये upward 10 जाएगा. बाद में यहाँ तक 10 रहेगा क्योंकि there is nobody
Constant.
here.
Yes.
It will be constant. Then to the right side जाने के बाद 10 minus 10
0.
0 रहेगा. 0. ये then क्या होगा?
So then there will be no shear force in the middle portion.
मिडल पोर्शन में नहीं रहेगा ना, क्योंकि यहाँ लिया तो 10 minus 10 0 ही आ रहा है. यहाँ से
Yes,
फिर
sir.
स्टार्ट होगा एंड देन यहाँ से जस्ट टू द लेफ्ट कितना है? डाउनवर्ड आएगा, तो ये नीचे आएगा ना.
Negative.
एंड देन दिस विल बी लाइक दिस. So it will be negative, ये positive. Correct.
Yes,
So draw
sir.
the, so this will be SFD. Draw the bending moment diagram at home. Now let's take some quick problems. So these are the determinate structures. All of you know what is meant by determinate structures.
Yes, sir.
So determinates means what?
So we are number of reactions are equals to the moment.
So number of reactions equal to the equations, equilibrium equation. Number of equilibrium,
Yes.
equilibrium equations. तो कितने हमारे equilibrium equations? Sigma fx 0, sigma fy is equal to 0, sigma m is equal to 0. So there are 3 equations and reactions. अभी हमने जो problem लिया, ideally speaking, इसमें कितने reactions है बताओ?
2 reactions.
हाँ 2 है. थर्ड भी है लेकिन वो 0 आएगा. ये h हमारा 0 है. So there is a f, ये h रहेगा, ये v रहेगा और ये m रहेगा. So there are 3 reactions, v, h and m. So 3 reactions and 3 equations. So this is determinate structure, simple structures we can say. And we are taking the problem of simple say. And see, determinate structures we can do it manually easily actually. Indeterminate are difficult to calculate. We need to use very, we can say, rigorous methods like moment distribution, slope deflection, stiffness matrix, and so on. See, we are not going in detail of those, we can say, rigorous methods, because we have the softwares to do the indeterminate structures. Only as a structural engineer, we should be in a position to judge the results, whether they are correct as per the common sense, and whether their values are justified. So do you agree with the values given by the softwares? Simple. And to understand the indeterminate structures, determinate you should know first. That is the aim. Now let's say we are taking one more problem. अभी quickly लेंगे चलो. So there is a, so all of you know that there is a, we can say, cantilever backup beam, we can say, right? And let's say we have a point load here, something maybe 600. Let's say this point load is 300 kilonewton. This distance 2 meters. This is also 2 meters, 2 meters. Okay. This is A, B. Now tell me what is the reaction at A? How to calculate? If you don't know, take the moment about A and then बताओ. Sigma m at A is equal to 0. ये equation करना है हमें. Quickly, 600 into 2 minus RB into 4 plus 300 into कितना?
6.
Gmail वरती.
So RB का value क्या आएगा? Will it be positive or negative? Positive. So कितना है ये? What will be RA value? 6 plus 3, 900. 900 minus 750 will be 150. So it is 150 and this is 750. You have the reactions. Will there be any moment in this? Support पे moment रहेगा क्या?
No, no, sir.
Yeah, because see, these are pin supports, hinge supports. Now बताओ shear force diagram. Shear force is very easy. Moment may be a little tricky. यहाँ मेरा एक पॉइंट है सपोर्ट पॉइंट, यहाँ एक सपोर्ट पॉइंट है. टेल मी shear force यहाँ 150 है तो ये linearly 150, correct? This value is 150. बाद में यहाँ तक constant. Then to the right side कितना आएगा? 150 minus 600. How much is the value? 150 minus 600. 450.
450.
ये 450 रहेगा मेरा. Then 450 थोड़ा बड़ा निकलता हूँ मैं. Just show to the scale. So ये मेरा 450 है and then till this point कितना आएगा? Same ही आएगा, constant. So it will be constant till this point. Then what will be the यहाँ तक क्या रहेगा shear force? Okay, just to the right of the support. 150 minus 600 is minus 450 plus 750. How much?
300.
And the value is positive. This is positive, this is 300. Negative. Shear force. Now tell me with the bending moment. Bending moment at this point. ये तो मेरा ये supporting point है ना. So ये, what is this bending moment at this point? A. और ये मेरा B है. कितना आएगा A पे?
0.
0. A पे 0 आएगा. What will be the bending moment at this point? Let's say this is C. कितना आएगा? 150 into 2, right?
Yes, 300.
Clockwise मतलब 300. Clockwise मतलब क्या है हमारा? Left clockwise.
Sagging.
Negative. Sagging, right? That is positive value. And generally, by observation, where will be the rather what will be the deflected shape? Just draw this first for understanding. ये मेरा deflection कैसे होगा बता सकते हैं क्या? So this will be something like this. You can imagine. ये ऐसे होगा and अभी ये उल्टा होने वाला ही है. ये कैंटिलीवर है ना? So just imagine ये ऐसे कहाँ तो आएगा? Then it will change its shape. ऐसे direction shape change करेगा. And then it will again is it convinced? So, yeah, this is very fundamental part actually. Do you feel this will behave like this? Understanding the deflected shape is very much important to understand the behavior. If you are not understanding, try to see deflected shape of different say problems. Either you can do this, try to imagine first, and then you justify your imagination through softwares like STAD or ETABS, and look at the deflected shape and ETABS. Then that will develop the understanding of the deflected shape. Or you can prepare your models also at home. Just take some say any material which is flexible, consider that as a beam, and then put the load, put the supports, and just see how it is deflecting. So that is also one of the way of understanding the deflected shapes. Then observe the different structures whenever you see which are very less stiff, we can say flexible structures. If you observe, then you will see the deflected shapes. For example, you might have seen the tents like that, tent structures like this. So you can see the deflected shapes very easily. So those structures which are very flexible, the deflected shape is very, we can say deflections are very large, and you can visually see the deflections, because as far as the beams are concerned, they are generally RCC or steel, and they don't deflect. They internally they are deflecting like this, but the deflection values are very small, so you cannot see the through your eyes. This kind of deflection you cannot see through your eyes, because the members are quite stiff and the deflections are very less. But for understanding the behavior and for calculation, you should understand this. So you can use softwares for this. But for simple problems, at least you should understand this. You develop your judgment for drawing the deflected shapes. So you can see यहाँ sagging हो रहा है, तो we will draw the bending moment here. So यहाँ मेरा bending moment नीचे रहेगा, the bending moment, and on this side you can see that the tension is on the top. You can see by common sense you can see that there is a tension at the top, क्योंकि deflected shape देखो ऐसे है, ये ऐसे है deflected shape, right? Here you will see the deflected shape is like this, and here you can see the deflected shape. ये हाँ है, मतलब यहाँ tension है मेरा, this portion. Okay, so this is a tension, this is a tension. So you can understand that the bending moment here it will be at the bottom, and at the top there will be tension. यहाँ भी रहेगा ना, cantilever है. So the bending moment diagram will be somewhere here in this zone, and in this zone it will be at the bottom. So that is our, we can say, judgment by common sense by looking at the deflected shape. So somewhere this bending moment will be at the bottom and this bending moment will be at the top. So from which region ये point दिख रहा है? This is point of contraflexure where the bending moment is 0. How do you understand whether it is a point of contraflexure? Anybody please from you?
Shear force will be 0 at that point.
Yeah, mathematically we can say shear force is 0, and physically how do you understand whether it is a point of contraflexure?
Bending moment is 0 at that point. Changes sign from positive
Yeah,
to negative.
bending moment is 0 and shear force generally is maximum at that point. So bending moment is 0, okay, but how do you understand physically? Through observation कैसे समझ में आएगा? So because bending moment is a mathematical equation, once you calculate that you will understand there is some point of contraflexure. This point is nothing but
No,
the bending moment at this
So
point is
there
0
will be no
mathematically.
deflection.
Yeah, so there is no deflection is one point, but rather there is no deflection. I would say it is changing its shape, deflected shape. So yeah, यहाँ तक ऐसे था deflected shape. Now the curvature got changed. So the first the curvature was like this, and now it has changed here. समझ में है? Now that is the point. So the curvature is like this in this region, and now it is changing its side, okay, or direction we can say. So this point is the point of contraflexure. Now you can see here, यहाँ से एक curvature ऐसे था. So you will say that there is a sagging moment here, and then from this point it is a hogging moment. Okay, ये sagging है ना हमारा, sagging, and ये hogging through observation. Now let's go to the bending moment diagram. अभी मुझे बताओ what is the bending moment at this point? A 0. Now let's calculate the bending moment at this point C. कितना आएगा? 150 into 2, 300 clockwise ऐसे रहेगा ना? And what does it mean? Positive. Yes or no?
Yes, sir.
So 300 will be positive. So अभी ये मेरा point यहाँ है ना? And as I am multiplying this force into distance, 150 into distance. So distance means x. So this into x means it should be sloping line. So यहाँ मेरा 300 है. Till this point. Yeah, this is 300, which is positive. Now I'm not calculating it. Abhi, tell me what is the bending moment at point B from the right side. Abhi thoda left side. Let's start with the right side. So you should know from drawing the BMD from left or right, whatever equation.
600.
300 into 600 and ये क्या रहेगा? Direction ये है ना?
hogging.
So clockwise right side पे रहेगा तो क्या रहता है वो? Clockwise right side. If you forget,
It will be
clockwise
negative.
right, negative मतलब hogging. So negative है. अभी ये मेरा positive मैं bottom को निकल रहा हूँ तो topward. So how much is the value? 300 into 2 is 600. So it will be 600. यहाँ कहाँ तो निकलता हूँ मैं. $600. If you take bending moment somewhere यहाँ के लोगे तो क्या होगा? कहाँ भी बीच में बोल रहा हूँ मैं. So it will be 150 into समझो ये 1 मीटर मतलब 3 मीटर पे निकल रहे हैं मोमेंट अब. So 150 into 3 कितना? 450 minus 600 into 1. करेक्ट है ना? Minus 150. Now it is changing its shape. So if you take any section, यहाँ छोटे-छोटे section ले सकते हैं आप, and then you will see that your diagram is following like this. ऐसे कुछ तो होने वाला है diagram. Okay? This will be negative. So you draw it. It's your homework. You know the procedure how to arrive at these numbers. So this will be your bending moment diagram for this problem. Quickly similar problem लेते हैं, थोड़ा अलग है. अभी by judgment बताओ मुझे इसका. So I'm not interested in the numbers. You know how to calculate that. But just discuss about the behavior now. Now there is the same problem. Of cantilever. But in this case now, I have the force here as a 300 kilonewton. Only. Nobody is here. Now tell me, let's say this is your 4 meter and same problem I can say. Okay, there is no force here. So what will be the deflected shape as per your common sense? ये इसको प्रेस करेगा. Now your common say, let's say we have a platform or some wooden plank and you are standing here. They are anchored here at this point, so they will not lift up due to hinge connection. We are anchoring some by bolt or something, let's say, and now you are pushing this downward. So what will happen?
So there will be downward deflection right of the
हाँ, यहाँ डाउनवर्ड रहेगा
second
and इसकी वजह से ये भी उसको this will
upward.
try to
There
go
will
upward.
be hogging,
Yeah,
upward
yeah,
deflection.
yeah. ऐसे कुछ तो रहेगा, right?
Yes, sir.
Was it convinced? You might have seen this platform whenever we stand on the wooden plank or something, and if it is anchored, it will behave like this. So develop this deflection understanding for different problems, and whenever the problems are complex, just go in the softwares, put the numbers, and see the deflected shape. Now you need to calculate the reaction. Reactions कितना रहेगा बताओ? You know that यहाँ से ये निकालना है आपको. RA RB, then take the moment about A and this. So see, as this 300 is pushing down, this reaction will be upward, and this will try to go upward. So the reaction will be downward. So you can get it through the equation also. I'm just going directly. So this reaction will be downward actually, RB, RA, sorry, and this will be upward. You can see through sign conventions, and this value will be minus 150. So I have this problem directly with me, and then this will be 450. And what will be the bending moment diagram? For homework for you. Okay. I hope you got all this.
Yes, sir.
Okay. Today we are going to stop early. But any questions from your side? Sorry. You can ask me any questions, either technical or general, whatever you want. Any questions? Are you finding these sessions useful for you?
Yes, sir. Yes.
Yes, sir.
Okay. Let me okay, quickly we will do one thing. Let's try to understand the. Do you know what is meant by free body diagrams?
Yes, sir.
I will do one thing. I'll just discuss that free body diagram, smaller example, and then we will stop today. Okay. So let's say we have a cantilever. And there is a point load, let's say W here. So what will be the reaction? W, and the moment will be M will be W into, let's say L is the span of this. Now, what is free body diagram actually? So we have actually already discussed here shear force. I have told you that at any section, the equilibrium equation has to be satisfied. So that means, see, we have seen here shear force, this was upward, the moment is clockwise, then there has to be at the same section to the right side, downward force 6 and the anti-clockwise 12. So it is equilibrium. So if you cut any section in the beam or in the member, at that joint to the left side and to the right side, it should be equilibrium. Means whatever the forces are to the left side of the section, there has to be equal and opposite on the right side. So that is the general, we can say, free body concept, free body diagram concept. And for example, let's say if I take just part of this section here, so this I can say this is a support, this portion is support, I'm just showing this, and this is your support. So if I cut this here near the support, exactly near the support, so I can say that what are the forces here near the support? Near means just exactly support I can say, but I'm for the interpretation I want to show. So what is the force at the support? So I'm splitting this beam here near the support. So this is my one part, and let me draw a second part over here. Yeah, I see. Okay. So this I cut over here. This is my cut portion. If I glue it together, then it will form again the same beam, complete beam. Now I'm cutting here. So whenever I cut here, so this and these sections are same. So what is the vertical force over here at the support? W. And what is the moment at this point? M, which is M is equal to WL. So as this is upward and you are cutting here, so there has to be some downward W here to balance it. यहाँ का section है मेरा. And what should be the moment? ये मेरा anti-clockwise है. That means there will be clockwise moment.
Clockwise.
And ये भी है यहाँ ना. So don't forget this. Now let's say मैं यहाँ भी cut करता हूँ उसको. And ये एक small part है यहाँ, which is W. I'm cutting over here. So I'm cutting this beam in 3 parts. So this is your W, and there is no moment and other forces, only W is there. So there has to be vertical W direction, right? Getting this? So this is the free body diagram generally used for the, if there are more members in the beams or frames, then it is useful. So we can split the beam, calculate the values, and then again glue it. So that is general, we can say, use of the free body diagrams. So I'll keep this problem as a homework for you, but we will solve it in the next session. ये से कुछ तो है समझो. You can try at home. Let's say this is your 10 kilonewton vertical force, and then there is a 4 kilonewton horizontal force. Is this determinate structure or indeterminate? ये बताओ पहले. Determinate है indeterminate? Can you solve this by equilibrium equations? How many reactions are there?
3 reactions.
As it is a fixed support, all of you know that in fixed support we have the moment and horizontal and vertical force V, Rx and H. So there will be some horizontal force, vertical force, and moment here. 3 equations, 3 reactions. So it is a determinate structures. And let's say the height of this column is 6 meters, and this beam's cantilever beam is 4 meters. The problem for you, and in that case, you need to split this beam here, get the values here at this point by splitting this from the column, and whatever value you get here in the opposite direction apply on the column, and again solve the column. So solve the beam and column separately whenever you calculate the reactions. So please draw the free body diagram of this beam and column. So split them. Okay. So this is your homework. We will solve that in the next session. And from next session, we will see some example of indeterminate structure. How can we do that approximately indeterminate structures? Okay. And then whenever the problems are bigger size, indeterminate structure, 3D models, and so we are using the software. So whatever we are learning, it is just for developing our understanding, developing the behavior, and developing the basic mathematical calculations. And then for complex problem, we will use the same basic concepts, whatever we are learning, for developing the judgment and checking the results. So that's it for today. Okay, any other questions, please? Hello. Any questions?
No, sir.
No, sir.
Okay, fine. So we will close today. So thank you all and good night to all.
Thank you, sir.
Thank you,
Thank you.
sir.